The third and final method that we're going to learn about for solving quadratics is the quadratic formula. And this will allow us to also find those roots, the x-intercept, zero, whatever you want to call it, the solution for a quadratic. And it has just a few steps here. So first off, we always want to check to see that anything needs to be simplified, rearranged, or remove a greatest common factor. And we want to be sure that your quadratic is written in standard form. You're going to need it to be in the standard form for the quadratic formula so that you have the values that you need. If the quadratic is a trinomial, we're going to use that b squared minus 4ac value again to find out how many solutions the quadratic will have. We're going to use that discriminant again. Then we're going to take the quadratic and set it equal to 0. And we're going to substitute the a, b, and c values into this equation, into this quadratic formula, and we're going to simplify. And so this is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so hopefully what you've noticed just by seeing that is that parts of this formula should look familiar to you. First off, the area under the radical, this expression, b squared minus 4ac, should look familiar to you because it's not only the discriminant, which tells us how many solutions the quadratic has, but it's also our factor test that tells us whether or not a standard form trinomial can be factored. So that part should look familiar to you. But not only that, this first part and the denominator, this part of the numerator and the denominator, x equals negative b divided by 2a. X equals negative b divided by 2a should also look familiar, and it should because this is the formula that we use to find the axis of symmetry of a quadratic function. So these pieces create the quadratic formula and allow us to solve a quadratic just with one formula. So in step 1, we want to simplify, rearrange, and remove our greatest common factors and make sure that it's in standard form, and that's exactly what we have here. Step 2 wants us to use the discriminant to find out how many solutions we're looking for. So here a is 1, b is negative 1, and c is negative 72. So we're going to plug those values in. So we have negative 1 squared minus 4 times 1 times negative 72. Now we're going to go ahead and plug that in the calculator. We get 289. That's a square, so it tells us that there are going to be 2 solutions. The square part of it doesn't necessarily matter on the discriminant. That tells us if it can be factored. It's actually the fact that it's greater than 1 makes this 2 solutions when the discriminant is greater than 1. Greater than 0. So we're going to take this and we're going to set it equal to 0. So x squared minus x minus 72 is equal to 0. Remember, we're replacing the y with 0 because when we're solving a quadratic, we're looking for an x-intercept. So if we think about a graph, an x-intercept is going to be a point where we go left or right on the x-axis, but we don't go up and down. So the y value is always 0 for an x-intercept. So if we want to find a x-intercept, we can always replace y with 0 and solve for x. And basically that's what we've been doing. We used factoring to solve it, and now we're going to use a quadratic formula to solve it. You can also use the graph and count it, but that becomes kind of difficult if you have a fraction or an irrational answer. Makes it just a little bit different and difficult to use that graphing method. So that's why we're learning other methods to find our solutions. So we're going to take these values. A is 1, b is negative 1, and c is negative 72, and we're going to plug them into that equation. So x is equal to, and here's our equation, negative is part of the formula. Then we plug in our b value, which in this case is also a negative 1. So the value of b is negative 1, but the negative out here is part of the formula. So be careful about that. You do need to have both of them. Plus or minus the square root of negative 1 squared minus 4 times 1 times negative 72. All of that divided by 2 times a, which is 1. Okay, so then we start to simplify this. So negative 1 and negative 1 becomes a positive 1. The plus or minus means that we're going to split this into 2 in just a minute once we get it simplified. Then we have the square root of our discriminant, which we just worked out up here, so we can plug that in, the square root of 289. divided by, and we can simplify that 2 times 1 to be 2. So here's where we can split this. We're going to have 1 plus the square root of 289. If we do the square root of 289 to simplify that, we get 17. So we're going to have 1 plus 17 divided by 2. But we're also going to do 1 minus 17 divided by 2. And that way we end up with 2 separate solutions, which is what we're looking for. That's what that plus or minus allows us to do. So 1 plus 17 is going to be 18 divided by 2, which in this case is 9. And then over here, 1 minus 17 is negative 16 divided by 2 is negative 8. So we end up with these two solutions, 9 and negative 8. And so our solutions, just like every other time, are written as a solution set. So we're going to write it least to greatest order in curly braces or the set notation. We get negative 8, comma, 9. And that's going to be the quadratic formula method for solving quadratics.